Here is the question number 31 from 13.1 NCERT class 11 book. So this is given, and they are asking to find limit x is tending to 1 of fx. This is given. So using this, we are supposed to find f of x when x is tending to 1. Right? So whenever we have limit goes to up and down to both. So let me write down a limit. It will go to x is tending to 1 of fx minus 2 divided by limit x is tending to 1 x square minus 1 is equal to pi. Can I take it this side? Okay. So it will be limit of x is tending to 1 of fx minus limit of x of tending to 2, because limit goes to both. If there is a minus sign in between, so I have given limit to this and to this, correct, is equal to pi times limit x is tending to 1 x square minus 1. In order to solve limit, we just need to put x is equal to 1, correct, everywhere. So this I don't know. This I am supposed to find this part. Minus, put x is equal to 1. Here there is no x. So it will be just 2 because there is no x. Correct? Is equal to pi into, here you put 1. So what will be this? 1 square minus 1. What is 1 minus 1? Is 0. So this is nothing but 0. Correct? So let me see now what we will get here now. So here it will become limit x is tending to 1 of fx minus 2 is 0. 2 will go there. It will be limit x is tending to 1 of x is 2. So this is my answer. Let's do next one. So this is the question number 32 from 13.1. So they are asking find m and n for which both limits exist. Limit x is tending to 0 will exist and limit x is tending to 1 will exist. So for that we have to find the values of m and n. Okay. So we know if the limit exists, so what should happen? If limit exists, LHL should be equal to RHL. Correct? So let's check at x is equal to 0. So what will be LHL? So as we have done it for LHL, it is 0 minus of f of x. So it will be limit x is tending to 0 minus, what will it take? Less than 0. Less than 0 we will take this one. So it is mx square plus n. And when we put x is equal to 0, it will be 0 plus n, which is n. This is LHL. Let's take RHL. To limit x is tending to 0 plus, for RHL 0 plus f of x. So where it is 0 plus, 0 more than 0 is this one. So this will become limit x is tending to 0 plus nx plus n. So when we put x is 0, it will be 0 plus n, which is n. In order for limit to exist at 0, what should happen? These two should be same because LHL should be equal to RHL. So can I say n is equal to m? This is first equation I got. Right? Because we have to find mn. For mn we need equations. So this is first equation I got for limit to exist at 1. Now what is the equation for limit to exist at 1? Let's try that. For limit to exist at 1. So let's try that. At x is equal to 1. So first equation we got m is equal to n. I am keeping it here. So let's find LHL. To limit x is tending to 1 minus f of x. 1 minus means where is less than 1. So this one we will take. It is limit x is tending to 1 minus nx plus m. Now put x is equal to 1. So it is n plus m. So this is my LHL. So what will be RHL? Limit x is tending to 1 plus of fx. So it will be limit x tending to 1 plus. 1 plus means more than 1. So more than 1 what we will pick up? This one we will pick up, which is nx cube plus m. Correct, we will pick this. So now let me put x is equal to 1. So it will be n plus m. So this is LHL and this is RHL. Correct? So for limit to exist, what should happen? LHL should be equal to RHL. So I am getting this is equal to this. This is n plus m is equal to again n plus m. This is my equation 2. Okay. So if we see to exist the limits at 0 and 1, we got two equations where m should be equal to n and m plus n is equal to m plus n. So these are the two equations which are true for any integral value of n when m is equal to n. Whenever m is equal to n, at that moment both limits will exist. Okay, because when m is equal to n, then m plus n will also be equal to m plus n. So this is the condition for both limits to exist. Let's see first example. This is example 5. It says fx is 3x, find out derivative f dash x at x is equal to 2. Okay, at x is equal to 2. So what is the formula for to find a derivative at any point? So dfx by dx is limit h is tending to 0 f of x plus h minus f of x by h. This is a general point. The derivative is general point. Later we can put x is equal to 2. Okay? To limit h is tending to 0, f of x plus h will be 3x plus h minus 3x by h. So what we got is h tending to 0, 3x plus 3h minus 3x by h. 3x cancel. Correct? So here h and h cancel. What I am getting is limit h tending to 0 is 3, which is 3 only. So the derivative what we are getting is 3. So no matter if we have f2 will also be 3, because the derivative of function itself is a constant. So at f2 will also be 3 only. This is my answer. Let's do next example. So this is example 6. This is very important question. Here we will learn how to find the general derivative of this function. Once we find the general derivative of this, I will put it here for x is equal to 0 and for x is equal to minus 1 to prove this equation. Right? So first let's find out general derivative. Let me write it here. The general derivative, how do we write? df by dx is defined as limit h is tending to 0 f of x plus h minus of x by h. Okay, so let me do it. H tending to 0 f of x plus h. So x plus h means the entire function with x plus h. 3 into x plus h minus 5 minus of fx, which is 2x square, 3x minus 5 by h. So it will be limit of h tending to 0. Let's simplify it quickly. Twice of x square, h square, 2hx plus 3x plus 3h minus 5. Correct? Then open this one. Here you know what I did, a square plus b square plus 2ab. This is what I did here, you can see it. A square b square plus 2ab, correct? Now I am opening this, 2x square minus 3x plus 5 by h. Correct? See it carefully. I am just simplifying it. Now if you see, I think 3x will cancel and 5 will cancel. Okay? And if we open it, let me open it and simplify it. Let's simplify it here. So it will become limit h is tending to 0, 2x square, 2h square plus 4xh. What is this? This is 3h minus 2x square by h. This is what we are getting. Right? Everything else is gone. This is 2 multiplied here, here and here. Then this and this. That's it, I think. Anything cancelling here? Observe carefully. Do you think anything is cancelling here? I feel this is cancelling. 2x square is cancelling. So let me write limit h tending to 0. Anything is common here. H is common. So 2h plus 4x plus 3 by h. Now anything is cancelling. Now what is cancelling here? Nothing. H and h is cancelling. Okay. To simplify, now we are just put h is equal to 0. So this will go to 0. What is the leftover is the derivative. So actually df by dx is 4x plus 3. This is my answer. So sometimes it comes, they will give a function to find the derivative by first principle. So this is my answer. But here there is one more part of the question. You can see it. There is one more part of the question that says f dash 0 and this we have to find out, correct? So let me see. What will be f dash 0? This is my f dash. See, derivative is nothing but f dash. Derivative df by dx is same thing as f dash. Remember, this is just one more symbol. Df by dx or f dash is same thing. So f dash 0 will be 4 into 0 plus 3. Correct? I will put 0 here. It is 3. And f dash minus 1 will be what? 4 into minus 1 plus 3. It is minus 4 plus 3 is minus 1. Correct? So these two values, let me put here and check. So f dash 0 plus 3 times f dash of minus 1 will be what? This is 3. F dash x is 3 plus 3 times, what is this? Minus 1. So 3 minus 1 is 0. Hence proved. Correct? So this we got 0. So that's it for today. See you in next video. Bye everyone.